Now let's go ahead and look at this one. Hopefully you got the same thing I did. We know delta G is delta G0 plus RT ln of Q. So we can go ahead and plug all our numbers in. We know that for Q, we're going to have the pressure of the products over the pressure of the reactants squared. So we plug in our numbers. And we look at, in this, I didn't really mention this previously, but in this calculation, you notice that we're using a different value of R. This is 8.314 times 10 to the negative third kilojoules per mole, because R is 8.314 joules per mole Kelvin. I've switched from the liter atmosphere number because I want my answer to have units of kilojoules per mole. So you do have to think about which R value we're using in different applications, and I didn't really mention that earlier. So now as we plug in all the numbers, we start to multiply across and solve. This comes down to 0.69, so we get negative 5.40 kilojoules per mole plus the 2.479 times negative 0.36. Adding this all together, we get negative 6.30 kilojoules per mole. Since it's very slightly negative, delta G will go forward and it'll make more product. So now, when we think about what happens when we're not dealing with Q anymore, what happens when we've reached equilibrium? Well, when we actually reach equilibrium, then delta G is 0 because we're at equilibrium, and Q, the reaction quotient, becomes the equilibrium constant K. And we know delta G is delta G0 plus RT ln of Q. So now if we're at equilibrium, we can rearrange this. Delta G is 0, so 0 is equal to delta G0 plus RT ln of K. Now we can rearrange this to the popular form. Delta G0 is equal to minus RT ln of K. And this is the form that we will use most often when we're talking about free energy for a system that is at equilibrium. And we use the gas constant value of 8.314 joules per mole Kelvin. We call that the thermodynamic equilibrium constant, which is generally K sub P. If we have gases, we use K sub P. If we have a solution, we use K sub C. So let's go ahead and look at an example. K sub P for the following reaction is 1.7 times 10 to the 12th at 25 degrees C. If you look at this, it's a huge number. So that tells you that it's a very product-favored equilibrium. And if it's product-favored, it means it's going to go zooming forward. So the delta G0 we come up with should be a negative number. So now we always check and make sure it's balanced, and in this case it is. So we are given information about the K value, and we're trying to find the delta G0. Since it's delta G0, we know that we are at standard thermodynamic conditions, so my temperature in Kelvin is 298.15 Kelvin. So delta G0 is equal to minus RT ln of K sub P. So negative R, 8.314 joules per mole Kelvin, times 298.15 Kelvin, times the natural log of 1.7 times 10 to the 12th. So that's equal to negative 8.314 joules per mole Kelvin times 298.15 Kelvin times 28.16. That's the natural log of my K value. So delta G0 is equal to negative 69,810 joules per mole. I can keep 4 significant figures. Typically, when we have numbers this big, we convert them to kilojoules. So delta G0 is minus 69,000 or 69.81 kilojoules per mole. And this seems like a reasonable number because we would expect delta G to be negative, and we'd expect this to go forward because we have a very large K value. Now go ahead and you calculate K sub P for the reaction on the next page. You can pause the video. Now, this one, I hope you got the same thing I did. And this one is kind of interesting for sig figs. We'll look at this. I got 3 times 10 to the 24th. We know delta G0 is minus RT ln of K sub P. So delta G0 divided by negative RT is equal to the natural log of K sub P. We plug in our delta G0. We plug in R and T. We do have to think about the units because I have kilojoules here, and 8.314 is in joules, so it's times 10 to the negative third kilojoules per mole Kelvin. So the natural log of K sub P is equal to 56.5. I keep 3 significant figures. Now, taking the antilog or exponentiating, K sub P is equal to E to the 56.5. I have 1 decimal place here, so I can only report 1 sig fig, and I get 3 times 10 to the 24th is equal to my K sub P. Okay, that's the end of this video.